Okay, hi, I'm Hynek. You may know me from the internet where I look like this, can be found at these places. Or you can actually know me from here, from last year PyCon. Anybody here who was last year at PyCon? Okay, Armin, why is your hand not up? So you may remember the joke that went around that the Wi-Fi speed was inversely proportional to our talking speed. So I'm aware of that problem, and I'm really trying to slow down. The talk is around 30 to 40 minutes. I have an hour, so we should be fine. You're also getting the more verbose version because I got only a short slot at PyCon, so you're getting the real deal here. So be glad you came. So I work at Variomedia, which you probably never heard of. We are a small German-speaking registrar, a web hoster. We sell domains, web hosting, email hosting. What I think that makes me relatable to you is that we are big enough to really need a proper solution to metrics and logging. But we are small enough that we have to do it on the side. We don't have a whole team just dedicated to metrics and logging, like maybe Heroku or something, which I would assume most of you are in the same situation. So, without further ado, this is the page to the talk, which contains all the links and projects I'm talking about. Please do not share it publicly yet. I would like to keep it secret, or halfway secret, until PyCon. But I didn't want to give you a second-grade experience, so I've put it live already. Let's start. When it comes to logging and metrics, I have basically 3 goals, and I will talk about that. The first one are errors. You want to get notified in time and properly, in order to so you can deal with them in a good way. Then metrics, because you want to know what your system is doing without touching it, without SSHing into it. And especially you want to know how your system is evolving over time and see trends. And finally, there's still old school logging. You have to do some bookkeeping, probably something like where did a customer log in from, or what did they do, and because they usually lie to you when they talk to support. So you want these logs to be accessible in a central place, for example, for your support staff, because you're not going to give out SSH keys to your support people. So that's it. These are my 3 goals. I will talk about all of them. And I'm starting with errors. Why? So errors happen. You have to deal with them. There's no way around. We are just humans. And there's also, in my opinion, the quickest wins to make, the least effort for the most benefit. So I start with it while you're still all awake. My requirements for error reporting is that I want to be reported. I want to know about it right away. This is straightforward. You don't want to know about your errors from a phone call in an hour from a customer. But I only want to know what it wants, because I do not want this to happen to me. I mean, anybody here ever had a mailbox with 500 unread emails because of some exception logger? Yeah. Don't be ashamed. It happened to me too. Okay, only once. And I want some context to the error, because you probably know these emails from Nagios. They are not helpful at all. They just tell you, fuck you, it's down. But you have no idea what's going on. It's a network problem. Is your application throwing errors? You have no idea. So naturally, there's a huge market for solution to these problems, because everybody has these problems. I'm in a fortunate position to just talk about one of them, which is Sentry. Sentry is pretty cool because it's actually an open source Python project built using Django. So if you're deploying Python services, you probably know how to deploy it already. And even if not, or if you like the concept of giving people money who do work for you, you can also use the hosted version, which is pretty much reasonably priced, including a free tier, which you can just use to test it out without any other effort for you. You can have error reporting within seconds, and then decide whether it's something you want or not. That's exactly how I did it. So, what do you get? First, you get notifications. In this case, an email notification. But there's a whole plugin system behind it, so you can have your notifications in Slack, HipChat, wherever. As you see, you already get some context with your error. A nice touch is also that it sets and reply to headers. So when I just hit reply on this email, it goes to my whole team. So if I'm somewhere traveling and I see the error on my phone, I can just quickly respond to them and give them some hints. What could it be, or what could they do about that error, which I really like. So the most interesting part, of course, is this little button up here, which brings you to the web interface. And there, my favorite part is this, because this button literally says, I've saved you 100 emails in your mailbox. So, I mean, Sentry has a lot of great features, but this is my favorite feature because I've embraced Sentry after I had those 500 emails in my mailbox. So, once you think you've resolved your error, you mark it as resolved, which reactivates email notifications. So if the error happens again, it gets marked as a regression and you get an email again. It's exactly what you want, exactly what you expect. It's great, believe me. Of course, this has been just a very small crop of the web interface. You get a lot of more data, a lot of metadata, which is to a large part collected automatically, so you don't have to think about it. And yeah, think of it as the Django stack trace view other people are still serving to their customers. So the question now is, how do you get this data in there? So the short answer is JSON via HTTP. So in other words, you can use Sentry even with assembly if you want to. There is really no binding to Python or any other technology. There's a bunch of official clients though, which all start with Raven in their name. And they make it a lot more convenient to use your to get your errors reported. So they support both multiple transports and multiple integrations. So transports are how the data is transported. For example, G-Event, the new shiny async.io nobody's using, or Twisted. And 8 others. There's a lot of them. Then there are integrations. Of course, logging, which is really nice. You just add a logging handler, and your exceptions will get submitted to Sentry. Django, I've said already that that Sentry is a Django app, so you can assume that the developers know a few things about Django, so the Django integration is top-notch. And also Pyramid and 9 others. So it's really easy to get started. So how does it look like? If you set one environment variable with the URL of the API of Sentry API, this is all you have to do. Unfortunately, it's a bit low, so the back rows can't really see it. I'm sorry about that. And it's literally one line. You instantiate a client, and then whenever you encounter an exception, you just call it client.captureException. No arguments, no nothing. It goes straight to Sentry. What I also like is that the client comes with a decorator, and whenever an exception happens in this function, it gets reported to Sentry. This is really useful when you have an application which is not Sentrified yet, which is existing, and may not be some web application, but just some one-off script or something. You can protect all your scripts with just adding one line, which is pretty cool. So proper integration is even easier. So if you're running Django, it's literally one line added to installed apps. And you of course get a lot more here because it is sentient about Django, so it will pull out metadata. And you can import the client wherever you want. It's really nice to use. So we've made progress. Deploy Sentry or give David Kramer a few dollars. Install Raven, add 2 to 3 lines to your application, and you have error reporting. And let me assure you that if you have no error reporting at all in your projects, you are missing errors. There are occasionally happening some errors you do not know about, and you will know about them later. So get it. Next up, metrics. So, what are metrics? Metrics are numbers in a database. Nothing more, nothing less. But on the other hand, they are clearly the difference between guessing and knowing. And of course, they are very complex topic, so I will not be able to really explain it to you in full width, but let me just assure you that you really need them, because if you want to make decisions, you need data, you need facts. Your gut feeling will not really help you there, and you can spend weeks working on something that will not solve your problem at all. So, and yeah, metrics are those facts you need there. When it comes to how you collect those metrics, I like to differentiate between system metrics and app metrics. So system metrics are things like the server load, or the current network traffic, like megabytes per second, or I/O, how much I/O is happening right now. And of course, there's literally unlimited ways you can measure your systems. On the other hand are app metrics, which happen within your app. So counters, when you're counting requests, or how often an error happens, like 404s or 401s. Then timers, when you want to measure how long your database queries take, or how long your requests take on average. And gauges. Gauges are basically just numbers you want to keep track of. That can be the number of online users, that can be the number of connections right now. There's a lot of things that are very useful to know how they are behaving. So, both are equally important, and they get much more useful when you start correlating them, but this talk focuses on app metrics. So, let me step back, and so what is the difference between this and metrics? So this is a single number, single value, which is mostly useless except there's an emergency, an ops fire if you want, and you need to figure out quickly what the hell is going on, why is the server not responding. On the other hand, this is priceless, because here you can see how it develops over the day, and more importantly, how it behaves over time. So you not only see it that every day at noon you're operating at 90% capacity, which will not work for you next week, because you see that it's rising. You see a trend. And you cannot see trends in single numbers. You can see trends only on time series, and only if you have a graphical manifestation of that. Then, of course, when you have such graphs, you can correlate them, which is even more useful. So, for example, why don't you look how requests per second correlate with the latency of your requests? That's one of the most important questions to ask, because then you know when you have to scale out. So, and since it's just numbers, still, you can do math on them. And one of the most obvious math operations you can do is if you have just a counter, which you count, for example, for requests, you can take a derivation of them and you get requests per seconds. But there are more interesting things. For example, what is the average request time for the slowest 0.01% of your clients? Because it might be a minute, but you will not know it because the average will smooth it out. So these are important questions to ask. They are called percentiles, and you usually want to break your percentiles down for 75%, 90%, 95%, and so on. What's important to say here that math is just as hard as you remember it from school, especially statistics, where you can get very easily some gut feeling which is wrong. So always remember the average human has one ovary and one testicle, but it's not very helpful information. So unless you know what exponentially decaying reservoirs are, do not do it yourself, but use software from people who do know what it is. There's really a lot of traps which can make your data or the interpretation of your data worthless. Then of course you can do monitoring on top of these values. So you can set a hard limit of acceptable latencies, and if it's exceeded, you get notified. Or error rates. If your 404s or 401s suddenly rise by 200%, there's probably something wrong going on. So either someone is running a DOS against you, or something broke in your app. And then, of course, anomalies, just in general. Again, if your requests per second double suddenly, there's something going on. It doesn't have to be bad, but you should want to know about that. And Etsy wrote a whole framework for that called Kale, which will detect automatically anomalies, and it will automatically also find values that change at that point. So it tries to find out for you what could be the factors for this anomaly. It's pretty cool. So we know it's numbers in a database. What database? You're probably not going to save your metrics in SQLite. What you want is a specialized so-called time series database. And I'm going to introduce you to three of them. I will start with the easiest one, which is Libradometrics. It's a paid solution. Yeah, it really sucks that I put the titles at the bottom. I'm really sorry. So it's called Libradometrics. It's a paid solution. You just post your data using HTTPS to it, and it will give you gorgeous graphs and dashboards and various operations on that. You can literally build a graph of your server load using curl, which I did. That's how it's really easy to get started, and then you can expand or use other software. Like the still main solution to time series data in, not only in Python, but in general, which is Graphite, which is written in Python. The front end is a Django web application. The back end is written using Twisted. The back end as in the network protocol, which is receiving the data from the clients. It's a bit oldish, but it's finally in Trusty, so you don't have to install it by hand anymore, so you can just use aptitude. It's a super widely supported standard of submitting metrics. So it's supported by most other third-party applications. As you can see, it's not the prettiest thing around. It's XJS. And the storage configuration is a bit finicky. So I understand you can't really change it afterwards, and it's not that much fun to use. But for the beauty aspect, there is a great solution called Grafana, which is just a dashboard building application for Graphite, basically. So it uses the data from Graphite, and it's just an interface to them. And I guarantee you, once you install this, you will spend at least 2 hours just playing with the graphs and making nice dashboards. It's a lot of fun, and as you can see, it's really beautiful. But Grafana does not support only Graphite. It also supports InfluxDB, which is basically the next generation Graphite written in Go, of course. They're heavily influenced by Graphite, and you can tell. But it tried to learn a bit from the mistakes that Graphite did. So it's much easier to manage its storage. It's easy to cluster. They have tags, so you can you don't have to make, for example, the server name part of the metric name, but you have just a metric name, and then you add metadata to it, like the server name, the worker ID or something. It offers a really nice SQL-like query language, and it offers a Graphite front end. So you don't have, if you are already using Graphite, you can make a direct switch. You just set up InfluxDB and keep sending the data to the new database. It has a company behind it which provides hosting, so there's some real interest to keep it cool. And I've personally got interested into it when I learned that it's used by Heroku for their metrics, so which is it's battle tested. So if you're gonna to set up a metrics database today, I would look into InfluxDB first, and only if that doesn't work for you, I would try to find something else. Okay, we have a database. How do we get data into the database? So there are basically roughly 2 approaches on how to collect metrics. The first one is external aggregation. The most famous one for that is StatsD. Another one is Riemann from a super smart person for other super smart people. Use it only if you're comfortable with configuring it using Clojure. This approach is basically something happens, you send a UDP package to StatsD, and they will do something with that. You don't care what. Or you measure something, a time, you just send it to StatsD. StatsD, or Riemann, will aggregate these values for you and make metrics out of it. But within your client, you have absolutely no state. It's super simple. You don't care about the data. You just increment counters. You just send out simple UDP packages. The drawback of that is, of course, that you have no direct introspection within your app. You need at least 2 more systems to see something, unless you want to use Wireshark and look at the network traffic. But other than that, you have no nothing without a StatsD server and Graphite or something like that. But it's super simple. It's super simple to get started. Very low overhead. Very popular. Then there's this. Oh, and StatsD and Graphite were basically what popularized by Etsy, and you can say that they started the trend to metrics going mainstream. So the second one is aggregation in your app, which on the other hand has been popularized by Coda Hale in his talk Metrics Everywhere, which everybody should watch. It's a longer talk than this, and it's just about metrics. It means that you measure within your app, you aggregate within your app, which also means that you get in-app dashboards. So you get a web view with your metrics. You don't have to look at other systems to see something, which is really useful. I really like it. So it's my approach I use. The drawback is, of course, there's state within your app. You have to do math within your app, which is not the best thing, but it depends on your taste whether you think it's a deal breaker or not. So how do you do this even in Python? As for StatsD, there's a gazillion amount of StatsD clients, and you can see here, it's really super simple. You create some client with the host name, and then you just increment numbers or do some timing. That's all, but you're not getting anything out of this in the app. For the second approach, the most popular way is called scales from Q. And as you can see, there's already more complexity involved because you have to somehow manage the data within your application. My 2 favorite metrics are the meter stat, which measures how often something happens. So you don't have to just count and then take the derivation. This is specialized for that. And PMF stat, which is a fancy name for timing. And this is how you use that. Once you have those metrics set up, it's just as easy. You just mark something, or you use the timer as a context manager. Once you do this, nothing happens really. There's just now some data in your app, and there are various ways how to get the data out of your app. So the easiest one are dashboards, which are provided by Scales. There's one for Flask, one for Twisted, and there's a third-party application for Pyramid. And this is what the meter stat gives you. And I really like it because it gives you the count, how we would expect, but also the average for last minute, 5 minutes, and 15 minutes, broken down. The timer is even cooler because you get the percentiles broken down right in the app. You don't have to do any magic more than that. And finally, you get all this data also as JSON, which means that you can use something like collectd to just collect your metrics and send out to your database. You don't have to do that though, because Scales come with a pusher, how they call it, which is just a fancy word for it starts a separate thread, and it sends out the metrics it aggregates in periodic intervals, in this case 30 seconds. As you see, it's really simple to set up too. Which means we have metrics tackled too. Yeah, sorry. Dramatic water pause. So, finally logging. Logging is not fun, and usually you avoid logging. For example, Armin is insistent that you shouldn't log at all, you should just increment numbers. I agree, but I have to do some bookkeeping. For example, on our mail service, we have to keep track where people are logging in. Because when they call us and say they've never ever logged in, we can prove them they are lying. It's stuff like that. So you will not get around of it. So you can just as well do it properly. And I cannot speak about centralized logging without mentioning Splunk, which is a big enterprise solution. It's huge. It's not just this web interface. It has a lot of views on your data. It literally has an app store for your data. So it's really huge. It's great, but it comes at a price. So the enterprise edition starts at $1,800 per year. They want to cater to the riffraff enough dudes, so there's some light version which still costs $900 per year, and you don't get a lot for that money too. I don't think anybody can get away with just the lowest quote. But yeah, it's really enterprise software. You will love it. The homepage is full of white paper, PDFs, and webinars, of course. So yeah, it's enterprise software. If you can afford it, it's great. And it works also on-premise and as a software as a service, which I find personally important, because that's what the next software does not. So there's PaperTrail and there's Loggly, which both I haven't used, but people I trust have used and told me it's great. I personally find it highly questionable to send my log files to a third party in the United States. I feel like I might get some more sympathy for the sentient here than I will get in Canada. But yeah, I don't think it's a good idea. It depends, but it's really easy to set up. They will help you, of course. So maybe it's a good solution for you. An open solution, of course, and the most popular now, I think, is ELK, the ELK stash, which is Elasticsearch, Logstash, and Kibana. How do they work? You have servers. These servers are producing log files, log entries. You send them to Logstash, which will parse them and add meaning to them. So they make them semantic. It's not just gibberish, but it's structured now. And this gets saved into Elasticsearch, which is a distributed and arguably easily distributed database with a focus on searching. So now your data is in Elasticsearch, and now you can use Kibana, which is just a web interface for Elasticsearch, to view your data, to search your data, to aggregate your data. ELK, E-L-K. A similar product is Graylog. It has kind of similar architecture. It also uses Elasticsearch for storage. And while ELK's Kibana is literally just a view on Elasticsearch, the Graylog server does much more. Because, and I'm quoting here, Elasticsearch is not a log management system. So, which is kind of true. Nevertheless, well, it really feels more integrated, less slapped together. It has something going for it, but it seems to me that ELK has one nevertheless. But you should try out both. I personally didn't find any reason to use Graylog over ELK, but your mileage may vary. Also, I'm not particularly fond of having a Mac vendor in my infrastructure. So, yeah. MongoDB didn't distribute that many Macs in Russia, did they? I'm very sure it's more fun in Europe. Anyhow, yeah, I don't like MongoDB. You need MongoDB. So for me, that's basically the death sentence for Greylog, but your mileage may vary. So the web interfaces, just very quickly, they do much more than just searching for your log entries. They can aggregate, correlate your data, they make nice graphs. As you see, Kibana has some geographical functions too. You can, again, you can play for hours with it if you want to, if you set it up once. So, how do you do that in Python? Or how do you produce nicely parsable data in Python? So, it's my utmost conviction that your log entries should look like this, except in one line. In the case of log slash, you literally say the first part is a timestamp, the rest is JSON. And it will figure out the rest, which is really, really convenient. So how do you get there? I think it's about context, because you want all the important data be part of the dictionary, and about format. You want it to be machine readable. I mean, JSON is just one example of a machine readable format. There are other ones. There are also native formats for the logging servers. Well, let's just use JSON as an example. And I think it's very tedious with standard tools to achieve. I think everyone who tried that will concur. So I was really frustrated by that, so I wrote a solution, and it's called struct logs. So anyone here heard of struct log? Oh, one. That's good. Two. Oh my god. Okay, struct log. What is struct log? Struct log is not a logging system. That's very important to stress. It's not a logging system. It's not a replacement for logging or for logbook or for whatever. However, it gives you a bound logger which wraps your original logger. Your original logger is still gonna log out the entries. So you don't have really to change anything on your logging setup. But additionally, it carries a context where you can bind key value pairs to it. Okay? And once you decide that you want to log out an entry, the entry key values get combined with the context and run through a chain of processors. And processors are just callables. It's nothing special about them. So basically, there's a dictionary going in the first processor. They do with it whatever they want and pass it on. And by the very end, the return value of the last processor gets passed into your original logger. So if you're having old school logging.logger, it's a string, probably. So your last processor has to convert the dictionary of key values into a string. But until then, it's just dictionaries, and you can do whatever you want. So for example, I've wrote myself a Sentry processor, which takes the context and sends it along with the errors out, which is super handy. And I really can't stress enough that it's really just dictionaries until the very end, until you have to transform it into something your original logger understands. And if you think about it, it's really great to have only data around there. So how does it look in when you're using it? You get a logger. The logger you're wrapping, it can be really any logger, is configurable. You bind values to it. And each log object is a new object. So there's no mutable state there anywhere. Ask your functional programmer fans. That's a great thing to have. And once you decide to log it out, all the values you've bound around along the way gets logged out. As you can see, you did not care at all about the format of the data or anything, because you shouldn't. You just have some values. You won't have to be part of the log entry. So you bind it to the logger, and it gets logged out at the end. This is the default development-friendly output rendering, which is just key value pairs using the wrappers. But of course, JSON struct log ships with a JSON renderer as well, and it works great. I'm using it all the time. When it comes to logging, the package, I'm convinced this is all you should do to your logging system. We live in a time of containers. So do yourself a favor and just log everything out to standard out. And I strongly recommend to ignore most of logging features. Unix had over 40 years to master the craft of log rotation, of adding timestamps to lines. You don't have to do it in Python. You don't have to reinvent the wheel unless you're using Windows or something, but please. So, also I heard that Python logging is rather painful to use, but maybe that's not the main reason, but I really like to keep it simple within Python logging because so many people got burned by it. So now you have JSON on standard out. What do you next? You just capture it. So for example, you can just redirect it into files, which you manage with your Unix tools. You can pipe it somewhere. You can send it to syslog or to a queue like Kafka or RabbitMQ. Syslog, for example, is great because it's a standard which, again, is supported by a lot of third-party products. You just have to be careful with the configuration because it drops log entries by default if there are too many, something you do not want to happen. And of course, you can pipe it directly into a logging agent. For example, the logstash forwarder allows to read its data from standard in. I'm personally a bit paranoid. I log only what I need to log out, so I do not want ever to lose a log entry. So I write everything into a file and have logstash watch that file and send out the data, the parsed data. It's still in real time. I'm not losing any time, but I have the security of ext4. I'm not losing data because of a network partition, which happens all the time. So I do not want to grep, but I still do not want to lose the reliability of being always able to look up what actually happened on a server. So I would like to, because there was a lot of talking, to put this all together. There are, of course, many ways to do that. I will show you mine. Maybe it's inspiring to any of you. So I'm binding data to a logger, and at some point, I log it out. Struct log makes JSON out of it, and logging sends it out to standard out. Unless I'm using Twisted, then I use the Twisted subsystem, which works just as fine with struct log. Okay, now it's on standard out. I'm using run it for to run my applications because Upstart is a pile of poo, and systemd is not on Ubuntu yet. So I'm using run it, which works great. And run it will add a timestamp in front of it, so I do not have to format timestamps in slow Python. And it saves it to a file. Okay, we have our data in a file, everything is safe. Now, this file is watched by logstash forwarder, also known as Lumberjack, I think. And it forwards it to logstash. Logstash will parse it and send it to Elasticsearch, and we are done. You can look at your data using Kibana. We have centralized logging. It's structured. Nothing is missing. Great. Which means we are kind of done. We are not, of course. So we have 3 components. But we forgot about the pragmatic part. So how do you put those 3 components together? Because do you want your code to look like this? Yeah, I'm so sorry. Even those in the backlight, it's just too much crap going on. You can hardly see the actual logic here in the jungle of measuring, reporting, counting. So I want it to look more like this, which is much nicer. So something happens, an error happens, so I send it to my logging system, and I'm done. So how do you get there? Of course, it may not be always possible. There are always cases where you have to be more verbose, but this is what I'm striving for. And so I would like to share some techniques to get there. When we come to errors, this is probably the easiest way because, as said, there's logging integration for Sentry. So you just log out your errors, and it goes to Sentry. There's some metadata missing in that case. That's why I've wrote the struct-log integration for Sentry, which solves just that problem. If you are writing web applications, you should totally embrace web applications error views, because then you can return an error ID to your users. So for example, in Pyramid, it looks like this. The return value of those capture exception calls to Raven returns the ID with which the error is saved in Sentry. So when your client is calling you, oh my god, everything is broken, you can just ask, okay, what's the error ID? And then you look the error up and you can fix it. You can map errors to people. And that's a really good thing to do. So even Armin agrees. And as you may know, Armin does not like a lot of things except Rust. So much to errors. Next up, metrics. It's a lot tougher to do, and this is probably the point where you will have more to pollute your code more. But generally, you should try to measure from the outside. So outside can mean outside of your models, outside of your views, or outside of your app completely. So for example, all major whiskey servers have some support for metrics to some certain degree. So Gunicorn has direct support for stats_d. You just add it to your command line, and you get some useful stats. MicroWhiskey, anybody who's ever used MicroWhiskey knows that it does everything what Gunicorn does, and like way more. They have a whole metric subsystem. It's super complicated. It's totally not documented, but there's a lot of data, including SNMP. So if you don't know what SNMP is, don't look it up. This means that by adding one option to how you run your servers, you get rough metrics about your applications without doing anything else. You just have to set up stats_d and some backend to it, and you have your data right there. There's nothing you have to add to your code at all. So if you want to go more specific, let's do a step towards your app and see what you can do with middleware. For example, this is from Pyramid, using scales. Tweens is the very awkward name from Pyramid's lingo, which is short for between. And this function gets called for each request with the request object. So you can just measure the request time like I do here. But since you have the request object, you can break down your times depending on what view is called. You can count your views. You can do a lot because you have the request object. So here you've got some nice timing without touching your views again. Then you can extract a lot from logs, because if you log something out, you don't have to count it too. You can do a computer make it for you. So log/ supports a lot of ways to gather metrics from your logs. It supports again stats_d, Graphite, Libretto, Riemann, and a lot more. The downside of that is that probably the log/ configuration file, which you need to alter to do that, may be under control of someone else, which it is in my case. So it's not a big deal, but it's still some friction for me to go over to my colleague and ask him to change the configuration, or to learn how to configure log/ myself. So again, I solved that with struct_log for myself again. If there's coming in a log entry, it is always an event. So I just count that events as metrics, and there I go. So finally, you can leverage monitoring for your own good, because I'm sure you have monitoring in place. Otherwise, I don't know how you sleep at night. And they usually measure execution times. So save those execution times, and you have a very rough idea what's going on. Nagios supports metrics in their checkers out of the box, so you can do there something too. It gives you an external view, which is not very precise, but it's still useful if you don't have any other metrics. So what's left? what do you have still to measure yourself? So there's certain code path. If you need to know how long they take, you will have to measure by yourself. For example, if you want to know how long your database queries take. But however, of course, you can put those metrics into the database code. Or if you have multiple major cases within your views. So for example, if your view sometimes hits the database and sometimes not. Averaging those two values, those average times, makes no sense at all because they are two completely different use cases. So you should time them separately. And of course, gorgeous. If you want to keep track of some number and see it somewhere, you will have to keep track of that number. There's no way around it. But still, it's still a lot less boilerplate for your code. And I find it's an acceptable compromise. So, where did we land after 45 minutes? We've hopefully accepted that error logging is important and that Sentry is awesome. We know that metrics are just as important and that InfluxDB is probably the future. And centralized logging will save you a lot of time, especially if your support coworkers are asking you for log entries all the time. And that you probably should use ELK nowadays because it seems to be the major player with the least components. And finally, we've talked about how to do this in Python with as little litter in your code as possible. So I hope everyone learned something and study the talk page, follow me on Twitter, and tell your German-speaking friends about Variomedia. Go forth and measure. Thank you.
Thank you, Hynek. It was very interesting. So, who has the questions? Если есть проблемы с задаванием вопросов на английском, задавайте на русском, я переведу.
For example, if you have an error which appears every time and you know that there is a bug in your library or some third-party component and you don't want to pay attention on it, how you ignore it?
Does this work? Yeah. You can mute errors in Sentry. Yeah. Yeah, you can do that. I mean, that's a very specific question that also depends kind of on your application. So there's no general answer. The most general answer is there is a mute feature in Sentry, because it happens that sometimes you have to cope with buggy code of other people. I heard.
Hi, I have a question on scalability. So Sentry is often used for websites, right? But I wonder how would it scale for huge log traffic? Say we have like megabytes of log data from a number of systems. Would it be able to, I believe it could be like
1 second.
Hundreds of megabytes.
Are we talking about Sentry error logging or about centralized logging like Logstash?
Well, I'm interested in both. I wonder how, because Logstash is a little bit serve on your own solution rather than provided by SaaS. As SaaS.
Oh, there's totally hosted solutions to the ELK stack too. But to your question, you can imagine. I can give you one example of a Sentry installation which copes with a lot of data, and that's the Sentry hosted service. There's a lot of ways to. So there's the very simple setup for Sentry where you just need a Postgres database and Redis for the workers. But you can go way beyond that. You can cluster it. You can use React for the errors, and it's all thought out. And as for Logstash and Elasticsearch is the same. You can cluster everything out. It all scales out. Especially Elasticsearch. It's basically if you accidentally start 2 Elasticsearch servers in one network, they will start clustering.
Thank you. Would you recommend running a local copy of Sentry or just outsourcing it to a main getsentry.com?
So David Kramer bought me a burrito once in Poland. So I feel obligated to tell you that you should give him money. But for me, I'm not comfortable sending out data that could contain accidentally some secret data of my customers to a third party in general. I'm just not comfortable with that, and Germany has pretty strict laws about this, or European Union in general. So I'm always going first trying to do something on premise, and only if there's no proper solution, or if the solutions are just much worse, then I do use something hosted. So for example, Slack is an example which we use, but we never share secret data on top of it. So we do our chit-chat on Slack, and when we need to share a password or something, then we go out to Jabber on our own Jabber server and share it there. So yeah, so I'm maybe not the best person to ask, because I really hate sending any data to a third party.
So another question, say we have a number of systems installed on a customer side, and we would like to gather the data from over there, over public networks. And so I wonder what security means are provided by Logstash or Sentry to carry the data securely.
Sentry works over HTTPS. So there's that, and Sentry, what did I say? So Sentry, HTTPS, and the Logstash forwarder uses SSL. It also does authentication using SSL certificates.
Okay.
So. Yeah, that's why I said accidentally, because there's just yeah, that's exactly what I don't want to think about.
How does it determine that it's credit card data?
Oh, look at the source code, it's open source. but credit card numbers have a very regular form, so it's pretty easy to see it's them. But I mean, it's not just very sensitive data like credit cards. It's also, if you have a mapping of email address and IP address, it's already some kind of tracking data you're giving to a third party, which might not be a big deal, but if you're running a hoster in Germany, people ask us a lot, so what's with our data? And we can always say all of our data is in Berlin in our own DC. Nothing gets out to Google, to Amazon, or whatever. So we are very sensitive to that, maybe oversensitive, but that's how we roll.
And maybe one last question. Then one additional thing about Sentry. Sentry is very useful for web application because it can handle not only backend errors, but they have JavaScript client and can handle errors that appears at the client side. So Sentry is a very cool thing.
It is, and it's really nice it's easy to set up. And again, just get this free account and play around with it. And if you like it, then set it up yourself. But it takes literally seconds to have a running Sentry for your little testing. And also, if someone wants to know more about Structlog or anything, just come and talk to me. I'm here all the time. People usually don't talk to me that much because I don't speak Russian. So
yeah, but we can help.
Yeah, don't be ashamed. I prefer broken English over sitting alone. So
nice. Thank you, Hynek. It was very cool.
Thank you.